All right, moving on. Let's look at the algebra of functions. It says for the given pair of functions, find the indicated sum, difference, product, or quotient. So as we look at problems 5 through 7, we're given a couple functions, f of x and g of x, and they're asking us to do a few different operations with these functions. And as we look at this first example, number 5, we're looking at finding the difference function, f minus g of x. All right, so we want to calculate the difference function. And as we do that, all right, let's go ahead and break it down. So f minus g of x is equal to f of x minus g of x. So again, what is f and g? So as you notice in this example, f of x is a linear function, 6x minus 2, slope-intercept form of a line, slope of 6, y-intercept at 0, -2, minus the g function, which is another linear function, 8x minus 8, again, another function, again, line, slope 8, y-intercept 0, -8. With that said, we want to find the difference. So with that, be careful when you're subtracting g, whenever g is made up of two terms. So we will have to distribute. So let's go ahead and clear parentheses. So 6x minus 2 minus 8x minus 8, that becomes a plus 8, right? Two negatives make a positive. And then we combine our like terms. So we have 6x minus 8x, that equals -2x. And then we have the minus 2 and the plus 8, which adds up to 6. So there's our difference function, right? -2x plus 6. And so again, finding a new function of x using one of our four operations, and plus, minus, right? Sum, difference, product, quotient. Now, with that said, we've got our difference function. All right, now it's another linear function. So altogether, we have three different linear functions now: f of x, g of x, and f minus g of x. Let's move on to problem number 6, and we'll do example what we call the product function. Right, we've got to find fg of x. So with the product function, so fg of x, right, we need to multiply f of x with g of x. So as we do that, we're looking at multiplying 5x plus 1 with 3x minus 2. So these two linear functions, now as we multiply, we need to be careful. We need to go ahead and distribute. All right, we need to go ahead and multiply these two linear binomials together. We can FOIL them. Distribute, right, 5x times 3x, that's 15x. We have 5 times -2, which is -10. And as we distribute the 1 through, we got 1 times 3x, which is 3x. And we have 1 times -2, which is -2. And then we're ready to simplify by combining some like terms. So we got 15x and 3x, so they add up to 18x. And then we got the two constants. We have the -10 and the -2. So they add together to make a sum of -12. So in the end, I've got 18x minus 12, right? As we multiply it together. Now, be careful. I've made a mistake. Somebody check that. You'll notice my mistake comes right here at the beginning. Right? Our first term, what happens when we multiply 5x times 3x? We don't get 15x. We get 15x squared. All right, big difference. So x times x is x squared. 5 times 3 is 15. 15x squared there as we multiply those together. So with that said, as we're simplifying and combining like terms, all right, let's go ahead and distribute back through, double check as we do that, our two terms here. Right. We've got what? 15x squared. and then that minus 10x. So let's go ahead and put in the 10x here. Go ahead and clear that out. All right. So minus 10x here. And then as we distribute the 1 through, that gave us the plus 3x minus the 2. So as combining like terms go, we have one x squared term, 15x squared, and we got two x terms, and their sum, of course, negative 10 plus 3 is negative 7. So we have a sum of negative 7x minus 2. So there's our product function. So here's fg of x, this product which produces a quadratic function. So these two linear functions, their product produces a quadratic function. All right, let's move on. Let's go to problem number 7. In problem number 7, we're looking at two functions, f and g. We got f of x being a linear function of the form 4x minus 2. G of x, a quadratic function of the form 2x squared plus 14x plus 2. And in this problem, they want us to find the quotient function, right, evaluated with an input of negative 3. So a little different than our previous examples, where this time we have a actual input for x, right? X is going to equal negative 3. So yeah, we're looking at f divided by g of negative 3. That's equal to f of negative 3 divided by g of negative 3. So let's go ahead and do the evaluations. So f of negative 3, well, that means we go to f of x. Wherever we see our x term, we're going to substitute negative 3 in place of it to find the value. So that'll give us 4 times negative 3 minus 2. And we divide by g of negative 3. Go to your g function, 2x squared plus 14x plus 2. Take out your 2x terms, those two x's, and plug in your input of negative 3. So that'll be 2 times negative 3 squared plus 14 times negative 3 plus 2. As we simplify, 4 times negative 3, we got a negative 12 minus 2, divided by 2 times negative 3 squared, which is 2 times 9, plus 14 times negative 3, which is a negative 42, and then plus 2. And simplifying that down, we got negative 14 divided by, 18 minus 42 plus 2. As we combine 18 minus 42, let's go ahead and add up left to right. 18 minus 42 is negative 24. Negative 24 plus 2 is negative 22. And then let's reduce. So we have a fraction with a common factor of 2. As we divide that common factor out, we reduce down to 7/11. So f divided by g of negative 3 holds a value of 7/11, right? The two negatives, of course, make a positive. All right, so that's evaluation of a function with an input. So they've given us a domain value. We're getting the output for it. So with this quotient function, we've actually found an ordered pair on the graph of the quotient function. When x is negative 3, right, we get an output of 7/11. So you can even write the ordered pair down here beneath it. Right, is what we found as a point, right, on the graph of f divided by g of x. All right, let's move on with our topic of the algebra functions, and let's look at reviewing the difference quotient, which is derived from our slope definition. So we look at finding the slope of a secant line. And a secant line is a line passing through 2 points on a function graph. On a curved graph, we can find any 2 points and find the line passing through those to get a slope, an average rate of change from point 1 to point 2, which is where this difference quotient is derived from, as we use it to define our derivative and define slope in calculus. Now, as we look at f of x, in this example, we have a quadratic function, as they want us to find the difference quotient, right? The difference quotient, which is f of x plus h minus f of x of h. Our first step always in looking for the difference quotient is to find the missing part of the difference quotient. which is f of x plus h, right? We're missing part of the numerator, right? The numerator, the difference quotient is f of x plus h minus f of x, which we're given, divided by h. So we got to do a little bit of work, and then we'll come back to our quotient. So what is f of x plus h? So we can go evaluate. So we're going to be plugging in x plus h wherever we see x in this f function. It's a quadratic. We've got a couple x terms. So 3 times x squared is 3 times x plus h squared minus 2 times x plus h plus 1. So there's f of x plus h, right? Out goes x, in comes x plus h. And now let's simplify. And of course, as we square x plus h, that means we need to multiply x plus h together 2 times. I'm going to go ahead and distribute here. Minus 2 times x minus 2x minus 2 times h minus 2h plus 1. And let's go ahead and take care of the square of x plus h, right? Let's go ahead and multiply these two linear binomials together. Let's go ahead and distribute x times x squared, x times h, xh. And then we'll go distribute the h through. H times x, which is another xh term. I'll write it in the same order. Doesn't matter the order of your terms. It is multiplication. It's commutative. So the order doesn't matter. H times h is h squared. And as we're looking at it, we've squared x plus h. We still got minus 2x minus 2h plus 1 here. And let's simplify. So what do we get with the square of x plus h? We have a couple of like terms. We've got 2 of the xh terms, so we'll go ahead and add those together. Plus the h squared minus 2x minus 2h plus 1. And now we can go ahead and multiply the 3 through. So let's go ahead and distribute. So 3 times x squared is 3x squared. 3 times 2xh is 6xh. 3 times h squared, 3h squared, minus the 2x is 2h plus 1. So here's the value of f with an input of x plus h. So that was our first step, right, to find that value. So now we can go ahead and find the difference quotient. So that's our second step. Right, calculate the difference quotient. Now as we do that, remember our difference quotient, which was stated up here in the directions. Again, dq, difference quotient, is equal to f of x plus h minus f of x all divided by h. So let's go ahead and plug that in. So f of x plus h, that's 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 1. I'll put all of that in parentheses so you can clearly see that's the value of f of x plus h minus f of x, which is given to be 3x squared minus 2x plus 1. So all that represents f of x. So there's our numerator of the difference quotient, all divided by h. And now we need to simplify the numerator. So I'm going to go ahead and distribute, right? Let's go ahead and subtract f of x, right? We got to distribute that minus sign to all three terms. So as we simplify, we get 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 1. And then distributing, if you want, we put a different color, minus 3x squared minus 2x becomes a plus 2x, and then a minus 1. And all of that is being divided by h. Now here's where it starts to simplify nicely. As you can see, we have some like terms showing up in the numerator. So we can see, for example, a 3x squared here at the front, and there's a negative 3x squared. So they eliminate, they cancel out. What else do we see? Like terms, we see a minus 2x, right? We see a plus 2x. They eliminate, they cancel out. And then, as we're looking at the ones, I have a plus 1, I have a minus 1, they cancel out. So in the end, it simplifies nicely. So my difference quotient, all I'm left with in the numerator is 6xh plus 3h squared minus 2h, all divided by h. And then I'm going to go ahead and factor out the h. So my greatest common factor, right, we've got an h in all three terms. I'm going to go ahead and factor that out so I can divide out the common factor. We're left with a 6x. We pull the h out of 6xh. So we factor out h out of 3h squared. We're left with 3h. We factor out the h from minus 2h. We're left with minus 2. And what do we have? The h's, they're common factors. So they divide out. So in the end, we found our difference quotient. 6x plus 3h minus 2. So here's the difference quotient. Calculating that quotient, we found it. All right. So again, that's a good application with the algebra of functions. We're working with a quadratic, a good test question, good example to look at. Continuing with our topic with the algebra functions, let's move on down here to problem number 9. 9 and 10 get into composition. And composition is just substitution of one function to another. So when I see f circle g, you see the little open circle. So again, this denotes composition. All right, so with that said, this is equal to f of g of x. So we got to evaluate f with a input of g. That's what f circle g of x is asking us to do. So let's go ahead and show that. So that'll be f of, well, g of x is given to be 3x minus 1. So as we evaluate the f function, we're going to plug g of x. We're going to plug 3x minus 1 into our x term, right? Our domain variable is x, our input. So out comes x, in comes g of x, which is 3x minus 1. I'm going to keep it in parentheses. So you can see I plug g into x within the f function. And as I simplify, now that simplifies down to what? 21x. 7 times negative 1 is negative 7, plus 11. Combining our like terms, we get 21x plus 4, right, with the composition. So there's our composite function. There's g substituted into f. Now I want you to notice composition is not commutative. So switching the order is not going to produce the same result necessarily. So you do have to be careful with that. Make sure you're reading it carefully. F circle G is different than G circle F in this example in number 9. Now, the only time they're going to be the same is if we're dealing with inverses, where they compose to the function f, x. So let's show that. Let's do a different order. So let's look at number 10. In number 10, it wants us to compose G with f. G circle f of x is equal to G evaluated with an input of f of x. So let's go ahead and do that. So it'll be g of f of x is this quadratic function, 4x squared plus 3x plus 5. So that means we're going to plug in 4x squared plus 3x plus 5 into what? Right here, into x and the g. So we're evaluating g. So that's equal to 3 times, again, plug in f of x, 4x squared plus 3x plus 5. So we just substitute f into the g function. So 3x minus 4 rewrites as 3 times f of x minus 4. And we'll go ahead and distribute. As we distribute, we got 3 times 4x squared, which is 12x squared. 3 times 3x is 9x. 3 times 5 is 15. Combine our like terms, the 15 and the minus 4. And we end up with 12x squared plus 9x plus 11. So there's our composite function. There's g composed with f of x. So that's composition. All right, now we'll change it up, and we'll show you decomposition. Create two functions, f and g, such that h is equal to the composition of f with g. So with composition, you take in two functions, put them together to make one. Well, with decomposition, you're taking one function, breaking it up into two. So we want this h function, we want to break it up. We want h to become two functions, f of x and g of x. What does f of x equal? What does g of x equal? Now with f circle g of x, all right, we want to find our first step. Step one, we want to find f of x. We want to find the parent model first because g's got to be substituted into f. And to do that, here's how decomposition works. We're going to create a new function of x based off the given function. Well, locate your x term in the given function. So we're given a rational function with h of x. So you'll notice our x term is down here in the denominator. So what I'm going to do is I'm going to replace that with x to create my new function here, which is f of x. So it rewrites as 1 divided by what? X. So out goes the denominator, and in comes x. So we've replaced x squared minus 3, right, with what? X. So again, that produces this f function. Now, whatever you take out, so now as we create the function g of x, you've got to use what you took out. So if you took out the denominator x squared minus 3, which we did, we're going to have to let g of x equal x squared minus 3. So there's our two new functions. So with decomposition, it's just like creating a puzzle. You've got to create two pieces that are going to fit back together to get the original. So let's check our answer. So remember, it says the composition f with g must give you h back. So let's do our check step. So we'll check it. So f composed with g of x. Let's see if it equals h. And again, by definition, that's f of g of x, which we said g of x is x squared minus 3. As we evaluate f, that will be 1 over x squared minus 3, which is equal to h of x. So it checks. All right, so that's one pair of functions whose composition gives us h back. And again, answers can vary. Isn't that the only answer? No. You could have taken out just the part of the denominator that had x in it. You could have taken out x squared and substituted it with x. Could have let f of x be 1 over x minus 3, and then g of x would have been x squared. So just ask yourself, where do you want to plug x in to create your new function? And you're going to do that where you see your x term. So in a rational function, x is down the denominator. So we take out denominator and plug x in it. Let's do another example. Let's find decomposition. All right, let's do decomposition here. Let's find f of x and g of x such that their composition will give us h back. So as we create f of x, all right, now I'm dealing with a power function. So what I'm going to do, I'm looking at a base here of 4x minus 11. So I'm going to take out that base, 4x minus 11, and I'm going to let it equal x. So that means f of x would be equal to, what, x to the third power. So replace 4x minus 11, right, with x to create this new function of x. So we end up with a function of what? X cubed. So again, that implies f of x is equal to x cubed. Now, g of x will have to be what we took out. So again, remember, it's like creating a puzzle. These two pieces must fit back together to get the original. So g of x is going to have to be 4x minus 11. So here's my answer. Here's my pair of functions whose composition will give you h back. So again, we can check it. So let's find out. F composed with g of x, which is equal to f of g of x. That's equal to f of 4x minus 11. Well, as we go to the f function, we take out x and plug in 4x minus 11. So f of x is x cubed. F of g of x 4x minus 11 cubed, which is equal to h of x. So it checks. That's decomposition. So that's a good review of the algebra of functions back in our previous section here in Unit 2. So we'll stop there and take a break, continue on.